Tired of confusing tech jargon? Welcome to The Why Explained. We cut through the noise to decode the systems and explain the foundational principles.
Hey there. So take a second and just look around the room you're sitting in right now. It probably seems, perfectly quiet, empty, right? But the truth is, flying through the very air around you at this exact moment is this chaotic, bustling highway of invisible data. We're talking text messages, super high-resolution photos, complex websites, heavy, high-definition videos, all just zipping right past your head. I mean, think about it. Maybe someone in the next room is streaming a movie, or someone else is downloading a massive work file, or just doom-scrolling social media. Somehow, all that incredibly dense information is moving invisibly through empty space. It's navigating around walls, dodging the couch, and hitting the correct devices almost instantly without a single wire in sight. Honestly, it kind of feels like magic, doesn't it? Okay, let's dive right into this. Because when you actually stop to think about the physics of our daily routines, it is absolutely wild. How exactly does this happen? How can information physically travel through completely empty space? You tap a tiny piece of glass in your living room, and a video physically stored on a server halfway across the globe suddenly and seamlessly starts playing in your hand. To answer that and demystify this whole modern miracle, we've got to totally rethink how we view the invisible space around us. Right off the bat, we need to clear up a huge misconception. A lot of folks use the terms Wi-Fi and the internet interchangeably, like they're the exact same thing. But actually, they're not. The internet is that giant, physical, global network of cables and servers connecting computers all over the planet. Wi-Fi, on the other hand, that's simply the wireless bridge connecting your specific device to that massive network. Its only job is to move info between your home router and your phone without a physical cable. But if there's no wire, what's actually carrying all the heavy data of that video? Well, the answer is radio waves. Imagine these invisible waves spreading through the air in all directions, exactly like ripples moving across a pond when you toss a stone in. And I know invisible waves sounds totally like sci-fi, but your room is literally already full of them. TV signals, cell phone signals, local radio stations, they're all bouncing around you 24/7. Wi-Fi just piggybacks on this whole concept, using specific radio waves to carry its own information. But wait, that brings up a pretty massive logistical problem. A radio wave is just a wave, it's a ripple. So how on earth can a simple ripple carry something as immensely complicated as a full-color, synchronized audio-video file? Well, to figure that out, we have to look at how computers actually talk to each other. See, computers don't see colors or hear sounds or read text the way we do. They only understand two symbols, 1 and 0. Yep, binary code. Everything on your device eventually becomes a massive, sprawling combination of just those two simple values. That vibrant family photo, 1s and 0s. Your favorite song, 1s and 0s. Even a giant cinematic movie is ultimately stripped down and translated into just an enormous collection of 1s and 0s. And this brilliantly illustrates how we actually transmit those 1s and 0s over the air. Just think of it like a simple household flashlight. Imagine you're standing across a dark room from a friend, and you turn a flashlight on and off in a very specific, prearranged pattern. Your friend could eventually decode that message, right? Well, Wi-Fi does something incredibly similar. But instead of visible light, it uses those invisible radio waves we talked about. And instead of a few slow flashes per second, it alters the signal millions or even billions of times every single second. It's basically a hyper-fast, invisible strobe light of data pulsing right through your living room. So let's track the actual journey here. You press play, your phone asks for the video. That request travels across the internet's physical cables, and the video data eventually arrives at your home router. But right here, the system hits a roadblock. Why doesn't the server simply send the entire video over the airwaves all at once? I mean, why not just blast the whole file over in one big go? Well, it turns out, managing huge pieces of information wirelessly is incredibly difficult and super risky. Let's use a practical, everyday household analogy to picture why. Let's say you just wrote a massive 1,000-page manuscript and you need to mail it across the country. If you jam that entire manuscript into one giant box and mail it, you are taking a huge gamble. If that one single box gets damaged in transit or lost in some mailroom somewhere, you lose absolutely everything. You'd have to start completely over from scratch. A much safer strategy would be to split that 1,000-page book into 1,000 different tiny numbered envelopes. Think about it. If envelope number 45 goes missing in the mail, it's no big deal at all. You don't have to resend the whole heavy book. You just resend envelope 45. The internet and your Wi-Fi router work in almost exactly the same way. Instead of sending one giant, fragile chunk of information, the system breaks everything down into tiny pieces called packets. A packet is exactly like one of those little envelopes. It's simply a tiny piece of a larger message. and it contains strict instructions on exactly where it belongs in the final sequence. A single short video that you might watch over breakfast could contain thousands or even millions of these packets, and each one carries a small fraction of the visual and audio info, along with the digital equivalent of a return address and a sequence number. So now that little plastic router sitting in the corner of your room has all these millions of packets ready to go. But obviously, packets can't magically float through the air by themselves. The router has to convert the packet information into those flashlight-like patterns inside the radio waves we just talked about. Those patterns are then broadcast outward through the air of your house. And here is where the sheer physics of this become truly mind-blowing. These radio waves travel at essentially the speed of light. To put that into perspective for you, in a single second, a signal traveling at this speed could wrap around the entire Earth more than 7 times. 7 times! That is exactly how fast the information is moving from your router straight to the device in your hand. But here's the kicker. Speed alone actually isn't enough to give you a flawless, high-definition viewing experience. It's also a matter of sheer volume and capacity. Modern Wi-Fi systems are absolute engineering marvels. They can send millions or even billions of bits every single second. And remember, a bit is just a single 1 or 0. That means your router is constantly broadcasting this unfathomably massive stream of information through the air, flashing its invisible flashlight billions of times per second. That is way, way faster than human perception could ever hope to notice. Now, all this incredible speed places a huge burden on the device you're holding. Eventually, those radio waves reach your phone. And your phone isn't just some passive screen, it's an incredibly active receiver. It detects the invisible patterns inside the waves, it converts those patterns back into digital packets, it rapidly checks the sequence numbers to see if any of those little envelopes got lost in transit, and if they did, it requests a resend in mere milliseconds, it places everything back into the exact correct order, and finally, it rebuilds the original video. And the crazy part? This isn't just happening once before the video starts. This rebuilding process happens continuously, right on the fly, while you are watching. Your phone is constantly catching new packets, assembling them and painting them onto your screen so smoothly that you never even notice the frantic construction project happening right behind the glass. So that explains a single device perfectly. But let's bring this back to reality. What happens when multiple devices want to communicate at the exact same time? Because, let's face it, you're almost never the only one using the network. Just think about your own household for a second. You've got your phone, maybe a laptop working in the office, a smart TV streaming in the living room, tablets, maybe some gaming consoles downloading hefty updates in the background. They all want to use the exact same invisible space at the exact same time. It's incredibly prone to network congestion. Imagine a crowded family dinner table where everyone just starts shouting their stories at once. Nobody would understand anything. It would just be pure noise. Well, Wi-Fi faces this exact same problem. To solve the noisy dinner table dilemma, all of these devices have to constantly listen, wait, send a quick burst of information, and coordinate with each other. They effectively have to politely take turns speaking to the router. This coordination happens so fast that we usually don't notice the pauses. But when too many devices are competing for the router's attention, when that dinner table gets just a bit too loud, the communication naturally becomes less efficient. The devices literally have to wait longer for their turn to speak, which is exactly why your Wi-Fi feels like it slows down to a crawl when the whole family is home at once. So let's bring this all together and trace the full journey one last time. Step 1, you press play. Step 2, the video is requested and broken down into millions of tiny numbered packets. Step 3, your router converts those packets into hyper-fast patterns inside invisible radio waves that blast through your room at the speed of light. Step 4, your phone catches those waves, decodes the patterns, and reassembles the packets in perfect order. And finally, Step 5, you watch the video without a single wire. No magic, no sorcery, just pure information being converted into radio signals, coordinating with every other device in the room, and turning back into a video, all in the literal blink of an eye. Ultimately, the crucial point to take away from this explainer is the sheer scale of the invisible world we live in. Perhaps the wildest part of this whole thing is that this incredibly complex, mind-bending process happens every single day, billions of times across the world, so smoothly and so reliably that most of us never even stop to think about it. Honestly, we just get annoyed if a page takes an extra second to load. But the next time you sit down on your couch and press play on a video, look at the empty space between you and your router and ask yourself, how many billions of invisible packets just flew past you in the last second alone? Thanks for joining me on this explainer, and I really hope you never look at your living room the exact same way again.
Now you know the why behind this concept. If you want to master the systems that run our world, hit subscribe for more foundational explanations.